In this video, we're going to be solving exponential equations. So we're going to begin with the equation 4 raised to the 2x minus 7 being set equal to 5 raised to the 3x plus 1. So what we want to do first is we want to take a logarithm of the same base on both sides. So just for fun on this one, to make it easy, I'm going to take the natural log. So the natural log on both sides. Now what that enables me to do is it enables me, let's rewrite it so it looks a little bit easier to read. So I'm going to take the natural log of 4 raised to the 2x minus 7. And then on the other side, I'm going to have the natural log of 5 raised to the 3x plus 1. Now from here, I'm going to take those exponents and I'm going to move them to the front of each piece. So now I have 2x minus 7 times the natural log of 4 set equal to 3x plus 1 times the natural log of 5. And this should be a 3x plus 1 like that. And this should be a 2x minus 7 like that. So from here, I want to essentially distribute this natural log of 4 to both pieces, the natural log of 5 to both pieces. So what that means that I'm going to have is I'm going to have 2x times, do it in red, the natural log of 4, then minus 7 times the natural log of 4. I'm going to set that equal to 3x times the natural log of 5 plus 1 times the natural log of 5. From here, I want to make sure that my x's are on the same side and that my non-x's are on the same side. So in order to do that, I am going to move over my 3x times the natural log of 5, which will make it subtracting. And I'm going to move over my natural log, or excuse me, my negative 7 times the natural log of 4 by adding. So you're going to see that in this next step. So I'm going to have 2x times the natural log of 4. And then I'm going to have subtracted, right? I'm subtracting because I'm moving it over. 3x times the natural log of 5. Then on the other side, I'm going to have that 1 times the natural log of 5. So I'm just going to write natural log of 5 because 1 times that is that. And now I am adding that 7 times the natural log of 4 to the other side. So I have them in the same sides. All right, so from here, let's give ourselves a little bit more room. All right, from here, I'm going to see that, hey, I've got a 2x and a 3x on each piece. So really what they have in common is an x. So I'm going to take that x out. So I'm going to take the x out, and that's going to leave me with 2 times the natural log of 4 minus 3 times the natural log of 5. Over here, I still have my natural log of 5 plus 7 times the natural log of 4. And at this point, because I have x times this piece right here, I can actually divide both sides by that. So 2 times the natural log of 4 minus 3 times the natural log of 5. So 2 times the natural log of 4 minus 3 times the natural log of 5. So again, these right here cancel out. And that's going to leave us with x equals. And I can plug this in. So what we're seeing right here, this piece right here, this is actually our exact answer. Or in other words, our solution set. But if I was writing this, let me just make that a little bit smaller. There we go. If I was writing this as a what would x be, I would actually plug that into the calculator, and I would get that x is going to be approximately negative 5.5034. And that would be my final answer if I was looking for an approximation. Let's go up and let's take a look at our next example. So here we have 4 times the log base 3 of 2x minus 7 equals 8. So what we want to do first is we want to isolate our logarithm. So we're going to end up dividing both sides by 4. So we're going to divide both sides by 4. Let's cancel out. So that now we have the log base 3 of 2x minus 7 equals 2. Now from here, we're going to rewrite this in exponential form. So we're going to take our base of 3, and we're going to raise it to that second power, which we got right here. And that should be set equal to that 2x minus 7 from right here. Okay, so there's our pieces. So we have 9 equals 2x minus 7, and we're going to solve from there. So we're going to add 7 to both sides, and that in turn is going to give us a 16 equals 2x. Make that a little bit bigger. 16 equals 2x. Then we're going to divide both sides by 2 to figure out that 8 equals x. And we want to plug that in to check it to make sure that it works. So we plug that back in here to our original equation. And we find that it does in fact work when we plug that in. So if you were wanting to check it and like, how do I check it? I would go 4 times the log base 3 of 2 times 8 minus 7. And I want to know, do I in fact get an 8 out of that? So that gives me a 4 times the log base 3 of 9. And from here, the log base 3 of 9 is a 2. So I have 4 times 2, giving me an 8. And I see that 8 does in fact match. And so that's how you would check that. So here we have our final answer of x equals 8. Let's go ahead and let's move on to our third example here. So we'll give ourselves a little bit of room. So we have here the log base 2 of x equals 3 minus the log base 2 of x minus 2. So in this particular problem, what we're going to want to do is move over this log base 2 of x minus 2 to this other side that has a log base 2 as well. So we're going to do that by adding. So that should give us a log base 2 of x plus a log base 2 of x minus 2. Remember, we're adding it to move it over. And that's going to be set equal then to our 3. Now from here, we see that we have 2 log base 2's that are being added. So we can actually condense this down into one log problem. So we're going to condense it so that we see that we've got the log base 2 of x times x minus 2 set equal to 3. Now I like to go ahead and distribute what's already inside there before I do that the next step. So I'm going to have log base 2 of x squared minus 2x equals 3. And now from here, I really want to get rid of that log base 2. So in order to do that, I could take 2 and make it a base. So I'm essentially going to take each piece and make it an exponent. And what that enables me to do is to then cross out this 2 and this log base 2. And it leaves me with x squared minus 2x equals 2 to the third power. So that means I have x squared minus 2x equals 2 to the third power, which is 8. Now from here, I'm going to subtract that over. Let me scoot this over and give ourselves a little bit more room. Right, so now I have x squared minus 2x minus 8 equals 0. And I either want to try and factor this, or do the quadratic formula to it, or complete the square. Now if I look at 8 and go, what two numbers will multiply to 8 but combine to make a 2? 4 and 2 pop into my mind, and I think that factoring might be a little bit nicer here. So I'm going to factor this into an x minus 4 and an x plus 2 and set that equal to 0. And that's going to give me two values, x equals 4 and x equals negative 2 when I use the zero product property. And now I just need to check them and go, gosh, does it work or does it not work? Because they don't always work. So I've got to check them. So I'm going to plug it back into my original equation. So way up here, I'm plugging it back into my original. That's where I'm doing the checking. So I'm going to have the log base 2 of 4 equals 3 minus the log base 2 of 4 minus 2. So the log base 2 of 4 equals 3 minus the log base 2 of 2. And because we have the log base 2 of 2, this actually gives us a 1. So we're going to have 3 minus 1 here, which is a 2. And the log base 2 of 2, when I evaluate that, that gives me a 2 as well. And we see that 2 does equal 2, which means that x equals 4 is going to be one of the solutions. But we also need to check the negative 2. So we also need to check the negative 2 again with our original equation. So we're going to have the log base 2 of negative 2 equals 3 minus, scoot that over, the log base 2 of negative 2 minus 2. So from here I'm going to have the log base 2 of negative 2 equals 3 minus the log base 2 of negative 4. And we have a bit of a problem because whenever we're taking the log of a negative number, we run into this issue of undefined, which means that x equals negative 2 won't work. So we only have the one solution, which is x equals 4.